Okay, the next lesson is on multiplying and dividing algebraic fractions. It's also my frog lesson. I think it sounds more like a pig than a frog. Anyway, so we're going to start by remembering how to multiply regular fractions. If we have 7/8 times 2/5, remember that you can multiply the numerators and multiply the denominators and then reduce. And I believe you did some brownie pan cutting and things like that last year, but this year we're going to just think about the procedure that you learned by the end of the year or by the end of the unit. And you would have gotten 14 over 40. 14 over 40 is can be reduced because there's a factor of 2 in 1440. So if I divide 14 by 2 and 40 by 2, I would get 7 over 20, which is my final answer. Now you can reduce a problem within the problem before you multiply. If I look at my numerators and I look at my denominators and I say, do any of my numerators share a common factor with my denominator? I can see that 2 and 8 both share a common factor of 2. So if I just had this problem, I could reduce the problem within it. I could say, okay, I'm going to cancel this and make it a 1, and I'm going to cancel this and make it a 4. Essentially, I divided each of those numbers by 2. Now I multiply whatever's left. 7 times 1 is 7. 4 times 5 is 20. And I get the same result that I got originally. So it's two ways to do a similar problem. It's two ways to do the same problem. Sometimes it's easier and sometimes it's not. But you'll see in the next situation that it actually is a lot easier. 28 35ths times 55 over 6. If I go ahead and multiply 28 times 55 and 35 times 6, I'm going to have a very large number, very large numerator, very large denominator. In fact, I need a calculator to do it. So what if I were to look at my numerators and denominators and find a common factor? Well, in 55 and 35, there's a common factor of 5. So let's let's divide that out. 55 divided by 5 is 11. 35 divided by 5 is 7. Okay, well now, there's another common factor in the numerators and denominators. 28 and 6 both share a common factor of 2. So if I divide a 2 out of 6, I get a 3. And then if I divide a 2 out of 28, I'll get 14. Well, guess what? There's even another one. The 14 and the 7. They both have a common factor of 7. And as long as it's a numerator and denominator, you can divide it out. 7 divided by 7 is 1. 14 divided by 7 is 2. Okay, now there's no more common factors left. So now I need to look at what's left and multiply that. I've got a 2 right here. So 2 times 11 gives me 22. 1 times 3 gives me 3. And I have 22 thirds. 22 thirds is equivalent to 7 1/3. And I'm done. Well, that was kind of fun. I've got another way to do that. I could take 28 35ths and 55 sixths, and I could write them in their prime factorized form. Now, I've already done that for you, so I'm going to skip that step because I hope you're feeling pretty good about it now. So, 28 in its prime factorized form would be 2 to the second times 7. 35 would be 5 times 7. 55 would be 5 times 11. And 6 would be 2 times 3. Okay, now the fun part comes. I look on my top and I look on my bottom and see if there's anything I can cancel. Are there similar factors there? The 5 and the 5. Well, 5 divided by 5 is 1, so the 5 and the 5 will cancel. This is just like you did in the last lesson. Well, the 7 and the 7 will cancel. Does anyone see anything else to cancel? There's a factor of 2 and another factor of 2. So the one on the bottom goes away entirely, and the one on the top, you're left with just 2 to the first. Okay, so now I've got 2 to the first times 11, which is 22. And there's nothing left over here, so it's actually just a factor of 1 over here. So 1 times 3 is 3. And I get the same thing I had before, which leaves me with 7 1/3. Well, I find that to be kind of fun. Maybe you will, maybe you won't. So let's cheer some applause. Hooray! Okay, and let's move on. Next page. So you're going to see these problems in the book. They're similar. Here's my frog. Does that one sound like a frog? Not sure. We're going to do this one using the prime factorization form because that's the format you're going to see within the book. So it's going to help you make more sense of it. So 7's a prime number and 5's a prime number. So I'm going to think about 7x to the third as 7 times x times x times x over 5 times y. I'm going to think as 15 in its prime factorized form as 3 times 5 times y over 3 times 7 times x. Okay, now the fun begins. I get to cancel anything that's on the top and on the bottom. You can't cancel two things that are on the bottom. You have to look for something on the top and on the bottom that's the same because 5 over 5 is the same as a factor of 1. And whenever you have a factor of 1, you can cancel it. So I see a 7 and a 7. That makes 1. I can take it away. I see a 5 and a 5. That goes away. I see a 3 and a 3. That goes away. Isn't this fun? X and X. Y and Y. Okay. Nothing left to cancel because all the things that are left are in the numerator. So there's nothing left in the denominator. Does that mean that it's 0? No. It means there's a factor of 1 left, even though there's nothing written there anymore. And the numerator becomes x to the second times y over 1. Well, anything divided by 1 is itself because of the identity property. So my final answer is x to the second y. I hope you thought that was as fun as I did, but let's go on. We've got one more to do. On the next page, and we get to hear one more frog, of course. That was the most familiar frog, I think. That's the one I'm used to hearing anyway. Okay, now this one is a little bit weird because it is this huge omongo fraction, a fraction within a fraction within a fraction. Well, the first thing to notice is that this is actually a division problem. So when I see all these, I have to locate the main fraction bar. Where's the biggest fraction bar of all? Well, it's the one that's in the middle. So I actually put a dot here. And I don't think that's mathematical. I think my math teacher just taught me that long ago, but it works for me. So now I know I've got 10 over a divided by 5a over 6. So I'm actually going to rewrite it. 10 over a divided by 5a over 6. Now the question is, do you remember how to divide fractions? Well, there's 2 steps you need to remember to do it. And I have a feeling, I know you did it last year with brownie pans, but it was kind of hard to remember what the rule was. Basically, your first fraction stays exactly the same. So I keep it as 10 over a. I change it to a multiplication problem, and then I've got to take the reciprocal, which means flip the final fraction. Okay, so 3 steps. The first one stays the same. I change division to multiplication, and I do the reciprocal, or flip, my final fraction. Now you've got a problem like you had in the last page. I'm looking for any common factors. So I see there's no variables in the top and the bottom that are going to cancel, but there is a factor of 5. I could prime factorize it, but if you can see it without prime factorizing, that's okay too. The 5 will become a 1, the 10 will become a 2 because I've divided a 5 out. Then all that's left is 2 times 6, which is 12, and a times a, which is a squared, and that's my final answer. And And that is multiplying and dividing fractions, algebraic fractions. Good luck.